Okay, so hold is check. Now यहाँ पे force किया हमने. Okay. After hold, it is coming out of the hold state. After hold. Okay. And if it is just the hold during this process, okay, so the processor will go to this part. Okay, that means after T20 checking, let's check already here. Can I show here? Because already hold is equal to 1, its answer no hai na. So I can show here also. Because this block is already tested there. So you can use some other thing. Get the point now. If hold flip-flop is equal to 1, hold flip-flop is equal to 1, ऐसा अर्थ क्या है? Hold जे केला है त्याच्या which state आहे hold. So processor again go back to the hold state. याचा आन्सर काय झाला समजत नाही. याच्या अगोदर hold च्या अगोदर hold equal to 1 असेल. याचा अर्थ काय? This is the temporary wait. परमनंट झालंच नाही. हे संपल्याबरोबर काय होणार? परत येतं जाणार. And if the hold that state that is acquired is during this process, ह्या प्रोसेस मध्ये कुठेतरी होल्ड जनरेट झाला असेल तर तो कुठे येणार? इथे येणार. Because generally hold is checked during the T2 step, during the T4 step if it is the first machine cycle, during the T6 step if it is of 6th machine cycles. Are you getting this one? Sorry, 6 T step. So here it will branch to this. That means this is the normal hold. If it is the hold after hold, then again it will go back to hold state. Okay? So just observe the thing now. Let us check whether the things are over or not. So I'm going to do this part. So if you have the space, don't draw the connector there. You have to continue with that. Otherwise, sir ने connector किया है यहाँ पे, so you are going like that. So you can draw this afterwards. Okay. So in different books you will get the diagram. Let us try to understand the concept. So I'll take the summary of the diagram. So we have started, just pay attention now. You can write things afterwards. So we have started with defining the different states of the processor. In all, there are 4 states of the processor. One is the reset state. Another one is the wait state. Third one is the hold state, and the last one is the hold state. After these defining 4 states, we have to raise the question: when processor acquires these states? So if we start with the first one, first state कौन सा है? Reset. So reset state is acquired by enabling the reset pin. Okay. What is the next state? Wait. Wait state is acquired by generating ready signal equal to 0. Hold state, third state. Hold state is acquired by raising the hold pin is equal to 1. And last state, hold state is acquired by executing the HLD instruction. Okay. The next question will raise like this one: what happens when processor enters in particular state? For example, if processor enters in a reset state, what is the effect? Very first effect is PC contents becomes equal to 0, 0. Next, what are the buses are there? All the buses goes in the try step. What are the internal registers are there? Those internal registers takes the arbitrary values. Next, what are the interrupt is there? This is very important. What are the interrupt system is there? That system gets disabled. And the last effect is reset out is generated. Now, what are the wait state is there? For this particular state, processor is adding the T states. In a normal operation, say you have T1, T2, T3, T4. This is the opcode fetch. Then you have T1, T2, T3, T1, T2, T3. That depends upon the type of instruction. But in abnormal conditions, when you have interface the peripherals, and if the peripheral is having slow operating speed, corresponding to this one, processor is checking this ready signal corresponding to T2 state. Corresponding to T2 of every machine cycle, ready is checked. And if ready is equal to 0, it will add the wait state. That means whatever your machine cycle is there, length of the machine cycle gets increased. Either by 1 T state, 2 T state, that depends. As long as ready is equal to 0, for that duration, your machine cycle gets expanded. And during this state, how processor responds? Processor just wait. What are the previous results are there? Previous contents are there. Those contents gets retained. Okay? Now, if you go for the third state now, third goes hold. So corresponding to the hold, what happens is, what the result is there, that result remains there. Only thing is, the buses control is taken by the another processor. Okay, so that means the response to hold, again it is checked during the T2 state. Response to hold is HLDA, hold acknowledge. And after completion of that machine cycle, that get this one. After completion of machine cycle, then only processor is entering in the hold state. यहाँ पे निकाला, you can have the same one. Okay, that means processor is not waiting for the completion of the instruction. This point is to be noted. After completion of machine cycle, processor enters into hold state if hold pin is activated. Okay, and once hold pin becomes equal to 0, again processor will take the charge of the different buses. And as far as the last state is concerned, halt state is concerned, processor acquires this state when halt instruction is executed. Halt is not the physical pin, it is the instruction. Are you getting this? So the result of halt instruction is the halt state. Here, internal halt flip-flop becomes equal to 1. And processor remains in halt state. That is what the processing is there, that processing stops. Then we have defined the 3 different ways to come out of the halt state. So one way is the reset the system, another is the interrupt the system, and the third one is generate the hold signal. So response to this one is you can have a temporary come out of halt, because afterwards once again the processor goes in forward state. Right? Now, how you feel now? Whether the things are difficult still? I'll repeat it twice or thrice. Okay? But sure question is that define the various states of the processor with a complete transition state diagram. Okay? The full question is there. So if you have any query,